This video is on simplifying radical expressions. You are already familiar with squares and square roots. Since 4 squared is equal to 16, the square root of 16 is equal to 4. Squaring and taking the square root are inverse functions. They undo each other. Raising an expression to the nth power and taking the nth root are also inverses. For example, if 4 cubed is equal to 64, then the cube root of 64 is equal to 4. And if 2 to the 5th power is equal to 32, then the 5th root of 32 is equal to 2. The number under the radical sign is called the radicand, and the small number inside the little v of the radical sign is called the index. Notice that a square root has an index of 2, but since square roots are relatively common, we don't write the 2. To simplify a radical expression, we want to look for factors of the radicand that are raised to the power of the index. Here's a couple examples. So here we have the square root of 54, x to the third, y to the 5th. So first I want to look at 54. 54 is 6 times 9 is what pops into my head. 6 is 2 times 3, and 9 is 3 squared. The index in a square root is 2, so I want to look for any of those prime factors that I can raise to a power of 2. So that's why I wrote 54 as 2 times 3 times 3 squared. Because when I take the square root of 3 squared, it's going to become just a 3. X to the third power is x squared. Remember, I'm looking for that index of 2 to make an exponent. X squared times x, and y to the 5th is y squared times y squared times y. Now each one of those values underneath that's in this radicand, expanded radicand, that is raised to a power of 2 comes out as just that value. So the square root of 3 squared is 3, the square root of x squared is x, and the square root of each of those y squareds is each y. Notice anything that isn't raised to a power of 2 has to stay in the radicand. So combining all of those terms, I have 3xy squared times the square root of 6xy. Same thing works with roots other than a square root. So here we have the fourth root of 162, x to the 9th. So 162 is actually 2 times 81, and 81 is 3 to the 4th power. So I'm going to write 162 as 2 times 3 to the 4th power. Remember, I'm looking to write part of the number with an exponent of 4 since my index, or the root that I'm taking, is a fourth root. X to the 9th is x to the 4th times x to the 4th times x to the 1. Recall that you're adding exponents there. So the fourth root of 3 to the 4th power is 3. The fourth root of x to the 4th is x, and another x to the 4th is x, and what's left is the 2 and this x over here. So this simplifies to 3x squared times the fourth root of 2x. So here's another interesting rule. If you are taking the even root of a variable that's raised to an even power, and the result is an odd power, we have to use absolute value bars. For example, the square root of x to the 6th is the absolute value of x to the 3rd. I'm taking an even root, a square root, which is a 2, my index is 2, of an even variable raised to an even power, my x is raised to the 6th, and the answer for that would be x cubed, which is an odd power. I need to use absolute value bars. Why is that? Because we are looking for the principal or the non-negative root. We know that because there's not a plus or a minus in front of the radical sign. I only want a positive result. So for example, if we say that the square root of x squared is x, this is true when x is positive, but it's not true when x is negative. Let's try it. Let's let x equal 2. So plugging in 2 for x, I have the square root of 2 squared, which is the square root of 4, which is equal to 2. That works. If x is equal to negative 2, then I have the square root of negative 2 squared. Negative 2 squared is 4. So the square root of 4 is not equal to negative 2. Instead, the square root of 2 squared is equal to square root of positive 4, which is equal to 2. So the square root of x squared is the absolute value of x because we are taking the even root, that is a square root, of a variable raised to an even power, x squared, and my result, my answer is an odd power, x to the 1, or just x. So keeping that in mind, let's take a look at several examples here. We need to simplify each of these radical expressions. The first one is the square root of 48 x squared y to the third. So I'm going to look for ways to write the radicand raised to the power with an exponent that is the index. So I'm going to write this as 48 is 3 times 16, and I know that 16 is 4 squared, so I'm going to write this as 3 times 4 squared times x squared times y squared times y. So when I take I can't take the square root of 3, it just stays that way, but when I take the square root of 4 squared, that gives me a 4. When I take the square root of x squared, that gives me an x. When I take the square root of y squared, that gives me a y. And then the things that weren't squared have to stay under the square root, 3y. So let's clean that up a little bit. Now notice that I did take an even root of an even power, and I got an odd exponent. So I'm going to need to put my x in absolute value bars, but not my y, because that started as an odd power, times the square root of 3y. So there's my answer, 4 times the absolute value of x times y times the square root of 3y. Number 2 is negative cube root of 54, a to the 4th, b to the 5th. So I want you to think of this negative as kind of like a negative 1 that's going to get multiplied by my final answer. So that's just going to kind of hang on out there, out front. Oops. Now let's look to write each of these as a power of 3. So 54 is 6 times 9, and 9. No, I don't want to write it as 6 times 9 because that's not it. I want to write it as 2 times 27 because 27 is equal to 3 cubed. There we go. So 2 times 3 to the third power. A to the 4th, I'm going to write that as a to the third times a. B to the 5th, I'm going to write as b to the third times b squared. Okay. So since I'm taking a cube root and that's an even index, I don't have to worry about absolute value bars, which is kind of nice. So I'll have negative 1 times, and now each of these that's raised to a power of 3 can come out. So times a 3 times a times b times the cube root of what's left inside there, 2a and a b squared. So let's clean that up. My final answer is going to be negative 3ab times the cube root of 2ab squared. I know it may not necessarily look simplified, but it is. And our last example here is 2 times the 4th root of 32, x to the third, y to the 6th. So again, this 2 out front is just going to be a 2 times whatever I have. And let's look to write each of these, anything we can in the radicand, as something raised to the 4th power, since my index is 4. So 32 is 2 times 16, and 16 is 2 to the 4th. So I'm going to write 32 as 2 times 2 to the 4th. X to the third, I can't do anything with that. That's just going to stay x to the third. And y to the 6th, I'm going to write as y to the 4th times y squared. Okay, and don't forget I had my 2 out front, and then this can come out as a 2. Can't bring out the x, but I can bring out this y, and leaving me with the 4th root of 2 x cubed y squared. And then let's clean that up. 4y. Oh, now wait a minute. I do need to look at absolute value bars because I have an even index, and I'm taking it of an even power, and I'm getting an odd result here. So my y does need to be in absolute value bars, times the fourth root of 2x cubed y squared. And there's my final answer. So in this video, we took a look at how to simplify radical expressions. You're probably familiar from Algebra 1 as to how to simplify radical expressions that are just square roots. But we expanded this to cubed roots, fourth roots. You can even do this with fifth roots and so on. And we looked at the case when you have to use absolute value bars, when you're taking an even index of an even power and you get an odd result.